when it comes to chain rule, in your exam, you have two types of application of that. Either you have to just apply in simple differentiation, or you have to build it from the information given in the exam question. And that sometimes can be challenging. So let's see. The volume of hemisphere is increasing at a constant rate of 450 centimeters cubed per second. So that is your first clue. Okay. Once they give you the rate, meaning they give you the derivative, you know that's going to be chain rule and you're going to be building it. So in this case, chain rule, we are considering when we are looking at the formula. Let's just get that formula from the table. So this is the formula. I'm just going to replace the beginning to see so that you can see it slightly better with du dx. So if you look at that chain rule, that involves, here is a multiplication sign. It involves three derivatives. Okay, each of that is a derivative. And the way we are looking at it when we are building it is as if we are building, I don't know, we are in kindergarten and we are building using building blocks. Look at that. So you have two blocks that are exactly the same. Then you have another two blocks that are exactly the same. And then you have the third pair of blocks that are exactly the same. So if we're thinking about colors, that's how it looks. I have, let's say, two blue, two red, and two, I don't know, purple. Okay, so that's the way we can look at that chain rule in a simple way. So I need three derivatives. So here they give me the first derivative. So how do I decipher? How do I know how does that derivative look like? It's the measurement. Okay, so here we have centimeters cubed, and then we have seconds. So seconds, what do we express in maths with seconds? Time, isn't it? And then centimeters cubed, meters cubed, whatever cubed, what do we express? Volume. So in this case, it is a derivative of volume and time. And don't forget, time always will be like x, independent variable. So they gave you a value of derivative 450. And because we have the word is increasing, therefore we know it's positive. So I got the first two elements. I have dv and I have dt. Okay, then the next thing they are telling us, find the rate. So this is the second rate to find. What kind of rate, what kind of derivative at which diameter, so meaning x of the hemisphere, is increasing with respect to time. So here I am looking for derivative of x and time. Like I'm telling you always, time will be always like x. And I'm looking for that derivative at a specific value when x is 20. So that's what I'm looking for. So then I have another two elements. I have the x and I have the second dt. So if I'm looking again as blocks, that each should be twice of each color, I can see it straight away. Well, what blocks am I missing? I am missing dv and I'm missing dx. So volume and x, the diameter. And then here they are reminding us, remember that the volume of hemisphere is. So that is the derivative that we can change into my dv dx that I am missing, the third derivative. So 1, 2, 3. So let's just create that third derivative. So pi over 12 will cross over, then 3 will go in front, and then multiply by x, and that 3 goes down in power, so power of 2. So I have 1, 2, 3. Now, which two am I going to multiply and which one am I going to equal? And again, you can see it, the one that has element on the top and on the bottom. So what element do I have? Which two have that element? Yes, dx here. So that means that my chain rule will be dv over dt equal, and it doesn't matter which one is first, which one is second, because it's a multiplication. Now, which one am I looking for? I'm looking for this one. So even before replacing, I can move that to the other side, this multiplication. So what am I going to do? I'm going to be dividing, isn't it? So it is divided by dv dx. And now I can replace that with numbers. So that was what? 450, 450 divided. That's the derivative that we created. What was that? 12 over pi. So 12 over, pi over 12 multiplied by 3 multiply. And we are looking for the value of that derivative when x is 20. So we can replace that x with 20 to the power of 2. Now just caution, when you are putting that in the calculator, make sure that's in bracket. Otherwise, you're going to get a wrong volume. You have to tell calculator exactly, excuse me, that you are dividing this number by all of this number. That number is as 1. And when we put that in the calculator, give your answer in centimeters per second, correct to 1 decimal place, we get 1.4. So that's the answer that we were looking for. So that's what I'm saying. Always remember, it's easy. It's about 3 derivatives and it's about the blocks. Each element is twice, yeah? And again, how do we recognize? When we are saying the rate is. And that's what we have here. The rate is 450. That means that we've gotten the value of the derivative. And when they are giving you the value of the derivative, then it will be a chain rule that we're going to build.